Welcome back, bros. Today, I hate it. We're going to look, we had 3 additional problems, and I just want to show you how I thought about them. I happened to make the right choice on the first step. It doesn't always happen. Like, even I will take a wrong step and go, nope, that sucks, and I'll restart. It does happen. The first one's, I hope, pretty obvious. What I saw a lot of you guys doing yesterday in class is you were changing them all to sines and cosines or 1 over tangent and all that. That's fine. My mind, and you'll see, I bet you do the same thing like 80% of the time, sines and cosines are so much easier. And right off the bat, if I just use this identity in purple, and I didn't justify it, there's no 2 columns. If we have to, we will, but I don't want to, so we'll probably won't. What identity is this? Cotangent is defined as cosine over sine. It has a name. Quickly, quotient. Love it. Okay, the second you make that substitution, these divide out. Notice I haven't touched the right side at all. I wind up with cos immediately. Now, I wrote this, and it's a habit that's hard to break. I noticed that I switched to theta magically. You can't. I'll probably be more lenient with you guys, but if you ever make that change, make sure it's noted somewhere. So it should say alpha, but it's the exact same proof. For the second one, I started with the left side. Did you? Okay, so awesome. When I looked at it, I noticed that there was a sine on the right side, and that was what I needed to get to. And I saw a cosine squared, and I thought, oh my Pythagoras. And I used this substitution. This is not exactly the way that we write it down. We write this down a little bit differently. We always refer to this, and I will always refer to this as sine squared plus cos squared is 1. I can do that in my head, and I can subtract the cos squared over. When doing this, I know that that means that this cosine gets replaced with 1 minus sine squared. Do my parentheses matter? Big time. Because if you don't put the parentheses, sine squared minus sine squared, they're gone. So here we are, sine squared minus 1 plus sine squared, and here we end up at 2 sine squared theta minus 1. And we're done. Now, could you start with the right side? You better be able to. Both sides need to be able to turn into the other. But if we look at it going downward through this middle one, that's when I start with the left. I could have started with this, and I'd be right here. But I'll tell you, I am not very confident that my first thought, if I started with the right side, would be to change this to this. But you could. Like, I can see that, hey, yep, I replaced this sine squared here. Sorry, what? What did they even do? I split it up. Sine squared plus sine squared minus 1. I wouldn't think to do that. That seems like an odd choice. But you could go from here up to the next step and then wind up here. Both directions, they work fine. Okay, this last one, I wrote so much more here than I would realistically. Now, I try to indicate on mine, and what I'll expect of you guys when we see these again, I expect you to write as much that I can follow it. So if you're skipping 5 steps and I can't tell what on earth you're doing, that's too much. Theoretically, anybody in class should be able to pick up your paper and see what you've done. But as they get harder, maybe that'll change. Just looking at it, I'm going to highlight a couple things. I would never write this part. I don't typically include that. But do you guys agree that I can do that? Why am I allowed to do that? It's 1. Cool. I multiply by 1. I would not write this step. My first line would be this one. Because I know that they're going to have a common denominator at that point. If you are comfortable doing that much in your head, I'm fine with it. If you're not, show that extra step. Once we got here, how'd I change from this line to this line? What equals 1? Sine squared plus cos squared is 1. Okay, in a similar line of thought, if this were my proof on mine, I wouldn't have shown this line either. Like, I would have changed it to 1 and split it up simultaneously. This would be a 3-step proof if I were to do this on mine. Anybody do it in 3? Cool. Now, with proof in geometry, anybody feel like you went all the way through geometry and never really understood proof? Okay, it happens. When I teach geometry, I stress that some people get it right away. Like, some people do. Their minds just click like that. Some people get it in January. Some people really start to get it in May. Some people never really get it. Proof is a pretty complex idea. Similar things are going to happen here, but we're going to make sure that like, I'll tell you never fail or pass just on your ability to write a proof. But your ability to try and be comfortable trying and being wrong is where you'll be graded with stuff. Cool. Overall, felt okay, felt awful. Better than geometry proofs, I think. Cool. All right. I want your assignment. You already have the ones that we checked yesterday, and a few more today. Cool. We just get a bunch of word problems today, so I'll come around and take those. Please number wrong from yesterday and today. I wouldn't count it completely wrong unless you just didn't try. So, we get 2 quick definitions and gonna be nice and chill. Cool. All right.
Oh, is there any way that you could not take this one?
Yes. Remind me toward the end of the hour. No, I'll look at the book. Okay. You got it.
I should have wrote some stuff outside of it, but
What do you mean outside of it?
like not in the homework. But I just like the triples thing and the.
Okay. No worries. I think I might have a question mark assignment. Nope, never mind. Ever told you guys I hate grading? You guys have been killing with the homework stuff lately. We might go back to the heads or tails version. Cool. All right. Today, we got pretty chill stuff lined up. You guys should have your books out. Grab your books out for me. Sorry, Angel and Mickey, for making you listen to me collect homework. Okay. We are going to do examples in our notes. Maybe. Probably 1 or 2. Word problems. Word problems. That's what we're doing. So, let's go ahead and dive in. We are continuing on from yesterday. This is still Chapter 4, Section 3, right triangle trigonometry. The last section that we looked at was like verifications, and I had to go to 2 here because there's a lot of notes. We gave ourselves a few identities, some new definitions. We have our cofunctions, our reciprocals, our quotient, and the Pythagorean identities. And then we just looked at some proofs and some application stuff. Kind of mathy application stuff. So moving forward beyond that, let's see here. I'm just going to get rid of the examples that I just did, or the 3 that I just checked here, and then we will knock it out. Delete. Doesn't work. Okay. Cool. So today, what I'm going to call this last section of the last little piece of 4.3 is just application. Now, we're using right triangle stuff, and we're looking at application. And 2 quick definitions, and then a slew of problems for us to just make sure we work with. If you're looking for a page, Riley, it's going to be like 289, if that's what you're looking for. Okay, right off the bat, 2 definitions that we're going to use, but do you think, like, are there many uncontacted tribes left around the world? Very few, and honestly, probably a couple within the Amazon somewhere that we've never seen because they're so small and reclusive.
Uncontacted.
Probably, like never, like even unknown and uncontacted. Maybe not. I don't know whether or not that's true or not. However, I do know that there are human beings that live in places without a formal mathematics education system in place, right? Like naturally. You guys agree with that? Where do they live? Like not where on Earth, but like at the end of the day, where do you think they sleep at night?
If they're like a real tribe like that, probably like a hut.
So I'm okay with a hut. Did huts just grow out of the ground naturally for them? No. Now, if they happen to build like circular huts, there's some more stuff with it. But is it possible that they have nice square huts? Or at least rectangular? Like, right? Like it could happen. Even here, the Aleuts used to dig homes that were rectangular plots in the ground, right? They didn't have a trigonometry textbook that they were working on. You think that people just naturally somehow discover these relationships with right angles, and at least how it applies to how strong stuff is? I would disagree with you. I think that anybody who builds a home, and like you might disagree, this isn't fact, right? This is just my subjective opinion. Anybody who builds a home, whether they're aware of it or not, they are using all the ideas here. They just might not be formalized. Even the Egyptians didn't have trigonometry. They didn't have an idea of sine and cosine and tangent, but they used right angles on their triangles, and they knew how to deal with them. They were doing trigonometry without the formal setup here. It is an innate thing that exists within humans in a culture. I don't think it's an innate idea and knowledge that exists within humans generally. I think there's a cultural component of it because I don't see chimps using a lot of right angle trigonometry. I don't spend a lot of time with chimps either, so I don't want to take that for what it's worth. However, sorry? Okay, cool. So, application-wise, super duper easy. 2 definitions that we need to get here, and I'm just going to use one single picture, and we're not even going to make wordy definitions. I'm going to suppose that we're looking at a horizon, which, if you look out, it's just flat. Is the Earth flat? No, but it looks that way because the Earth is huge. So check it out. I'm going to draw a person. You don't have to draw the person if you don't want to. But here's a person. And assuming that they have an eyeball, they look outward, and they could look horizontally. Parallel with the horizontal. Now you're going to see some weird problems where maybe they're buried and like their eye is level with the ground and things like that. Just depends on the situation. They could be on top of a cliff. Doesn't matter. In this situation, here I am looking outward. If you said, look, a bird, am I going to do this? No, probably not unless you said like, oh my gosh, it's a dodo, and I look down, right? They're going to look upward. This is one of the possible options that if we're using this to solve problems, you might get this. Now there's an angle here that gets formed with the horizontal. I'm going to call this alpha. Looks like a fish without the vertical bar on the tail. You can call it X or Y. I don't really care what you call it as long as you're consistent. When we look at this, only one of 2 options. And you guys had this vocab word already, so this is going to go super fast. Did that person go from the horizontal and elevate their angle in their vision, or did they depress it? Elevated. So this is an angle, and it's an angle of elevation. The worst hand gesture I've ever made as a teacher came from this. It used to be associated with somebody else, but nope, we're not going to make the comment. Never mind. That's where I was going to go, but my heart goes out to him. Okay, looking at it. That might have been too much. Sorry for that.
That was close.
Yeah, that's too much. But I mean, you can imagine exactly when I'm saying we're looking straight out and what happened. I still have nightmares. Okay, we could be elevated upward, right? We look up. Or the reason that it's called depression is one feels down, right? Like it is a weird little, I don't really know the etymology of it. That seems right to me. I'm going to say maybe we look down instead, and I'm going to use 2 arcs to indicate for sure that I'm not guaranteeing that they're congruent. I'm going to call this beta just for fun. Beta is not an angle of elevation. Beta is an angle of what? Depression. Angle, and I don't know why I'm not doing caps, but I'm going to roll with it, of depression. You can elevate upward or depress downward. Those are the 2 options. Everybody cool with that? Now, you're going to see this language show up over and over and over and over. So, I think we should do a couple problems and just get a feel for it. So, I want you guys, I will copy and paste it here in your textbook. Starting on page 287, or I guess starting on 286, is all the examples from the text, or from the end of the questions. Oh my gosh. End of section questions. Goodness. Consonants. Okay. I did not make a printout for you for this. I don't care if you write it in your notes, but I want at least one in our notes, and then we're going to get a ton of time for homework just to get practice. So here we go. I want us and you, whomever, I want to do number 67 in your book. So let me cover up the answer real quick because mine shows the answer. And I'm going to copy and paste, but we're looking at the Empire State Building. Once the tallest building in the world. Cool. I want you guys to read through this problem And we're going to draw this and solve it, but we're going to do it as a collaborative effort. So here we go, number 67 out of the section. I hate how dark that is, so I'm going to retry this. While I'm struggling here, you guys go ahead and read through that. Focus. What? Boom. Not done this problem. We're going to do this just straight up blind together. Now, in your notes, I would not write the whole paragraph if I were you. What I'm going to do on here is, anybody watching this should have access to the textbook. I'm just going to paste it. But in your notes, I would say, hey, this is page 287. And this is number 67. This is all I put in my notes. And then the work for it. But here's the problem. So, looking at it, we have us standing some distance, 45 meters from the base of it, and we estimate that we're looking all the way up to the 86th floor, and we get some angle of elevation. We know the height of the building is beyond that, and we're trying to find the true height of the building all the way. Now, there's always going to be something weird when we set up problems like this, because how do I know that there's 123 meters above this? Maybe there's a placard on the street that says, hey, the spire on top of this building is 123 meters tall. Cool. Now our problem makes sense. I want to be able to solve this. And through here, I don't really want to have to go through the find, known, and all that stuff like we typically do in physics. I think we can just solve this problem. And we can do this by maybe giving ourselves a nice visual aid to make sense of what's going on. That's a way. One more time. So you're talking about free body diagram. I love it, but we're going to keep the physics out of here for now. I'm just going to draw a picture. Am I going to take a lot of time to make a good picture? No. In fact, I love it. The only weird part about this is they never specify, so I'm going to because it drives me crazy. You're standing in a hole 45 meters away such that your eyes are exactly level with the ground. Because if I really want to know how tall the building is, if I'm 2 meters tall, you have to tack on 2 meters later. We're just going to say that your eyes are level with the ground, so we don't have to do that. Okay. Yep, we're standing. We fell through manhole. If your neck can handle it, we can be prone.
Like that.
You probably have to lay on your back if you're going to look all the way up, unless you're going to. Yeah. So we're standing in a manhole. Cool. So check it out. I don't really care where we draw stuff. I pretty much default every time to drawing in quadrant 1, which means I'm going to get real creative with my art. Here's a person. That's the person. They're standing on the flat ground. And I know that this person is how far away from the Empire State Building? 45 meters. Okay. Now, they are looking upward. And I'm not going to draw this to scale. I'm going to trust the numbers, not the picture. So here we go. Here's my Empire State Building. And then we get to the 86th floor. And I'll just put a mark here and say, look, there's the 86th floor. I'm going to label this as much as I can. And how much more above the 86th floor do they see? So 123 more meters. So 86th floor there, and then I'll change color just so it's really clear. 123 meters on top of that, right? Now, the only thing that I care about to make sense of this problem is there's an angle in here somewhere, but I see on the right side where my building is, I see 2 points to which I can draw my hypotenuse. 2. Does it go to the 86th floor or does it go to the top of the building? The angle of elevation to the top of the 86th floor. So I go to the 86th floor, right? So here's my line of sight. I'm going to do this one in white. Boom. There it is. Sweet. We are trying to find the distance between me and my buddy who is on the 86th floor, right? All right. So I'm going to give you about a minute or so. Play around with it, see if you can get it set up. I don't want to suggest any of the steps we take. I want to get them all from you, If they're wrong steps, I'm not even going to comment. We'll figure it out as we go. Cool. Talk it out. 2 minutes. Go. All right. So here we are. I think I need a couple more things labeled on my picture. I think. Fern, we made brief eye contact there. What else would you add to this picture? So there's an angle of elevation, which means it's from the horizontal. It's here, I hope. And what is this angle? 82 degrees. Now, you are allowed to make very few assumptions in life, just in general. This is one of them that you're allowed to make in math. Buildings are typically built how relative to the horizontal? Which means this is a what? Okay, you're allowed to assume that if you're not told with construction stuff. If we're building on a hill, we'll like specifically talk about that. Otherwise, cool assumption to make. So, Abigail, anything else that you added? Okay, I would add one more thing because there's a difference in, we're asked to find two things, right? Okay, the two things that we're asked to find look different, and I want to make sure that we're clear. This distance, if you were to measure from the very bottom of the Empire State Building to the very top, I'm going to call this the height. This is the height of the Empire State Building. Now, notice I didn't call it h, only because I don't want to confuse it with the hypotenuse. Okay, what about the distance from you to your friend? It's always a straight line if we're talking distance. So this is my distance that we're after here. Okay, just from those, we're getting pretty close to be able to sort this out. Now, maybe the calculations come out funny or maybe they don't. We'll see. I'm open to volunteers if somebody wants to give me. Sean, what you got? So the tangent of 82 degrees, I don't like that it's theta because we've already used our angle theta. The tangent of an angle represents what? Which sides? You're right. Opposite and adjacent. Well, what's the opposite of my 82? Sure. I'm not going to use alpha only because alpha is typically a letter, or sorry, a angle. Can I call this A? Cool. A over 45. So A is exactly equal to 45 times the tangent of 82 degrees. Okay, so I like that. Let's go ahead and I know that A is this, and the height then is just A plus 123. That's the height of the tower. Everybody cool with that? Okay, on your calculators, I want everybody to physically try typing this in. I know I didn't write any numbers because they're going to be ugly. I'm not going to round. I'm just going to let my calculator number with all 11 digits follow behind. With trig stuff, the standard that I use is 4 decimal places. That's my standard, which is why exact is always nicer. But I want you guys, let's go to 4 throughout the whole problem, at least 4. More than 4 is even better. But in the end, I'm fine if we round it to tenths once we get the answer. Yeah. Somewhere. I don't know if it's in radians or degrees, just so you know. Do you have one in your desk?
I got one.
Make sure you type it in. I want to see that you get the same thing. I think it's 443.
You gave some out to people, right?
Some of the extra ones, yeah. 443. So height is approximately 4, and I'm going to be crazy with this. I'll just write my answers here. The Empire State Building, we're just going to shorthand it, is about 443.2. Is that what it comes out to? Okay. 443.2. And I'm fine here once we get to the very end around, but just don't do it super early. 443.2 what? Meters tall. And I'm not even going to try to be fancy with my sentences. I'll write 3 distinct sentences. I don't care. I'm good with it. Which means Well, that's it, right? Just how, there. So, okay, so I'll go ahead and just write this in my picture now that we have it, 443.2. Now, we have two of the three sides of the triangle. That's 343.2. Thank you, Sean. I'm going to make the claim that it didn't really matter what I wrote there because, what's up? Oh my gosh, will you guys tell me the number?
320.19.
I probably should have been able to do that. But 320.2. Everybody good with that? Okay. Now, I'm going to make the claim that whatever I wrote there is irrelevant because it's not going to dictate my answer whatsoever. There's two options that we have from which we can choose to find the distance along that diagonal, right? Okay. If I was worried about it and you were worried about it, that's good. You should worry if we're mislabeling stuff for sure. I would not have made a mistake in solving the problem though. Could you use Pythagorean theorem? Absolutely. Am I going to? What could I do instead of Pythagorean theorem? So you could use cosine or sine. I'm going to make the claim one of those is better for this situation. And I'll even tell you, I think cosine's better. Why is cosine better than sine? Well, I have the x, but I also have the y. So the whole number is partially kind of. This is exactly given to me. This is approximated by us. The exact answer or the exact value that's given is always a better, more reliable value to use. I'm going to use the adjacent leg, that 82-degree angle, and which function to find the hypotenuse? Cosine. So, gosh, it's just rough because it's a Friday. Man, Barsega, what's the cosine of 82 degrees going to be based on this picture? I just don't remember how cosine works. 45? Cool. I'm going to call it the hype. Can we call it H? I'm fine with that if you guys are cool with it. Or C, whatever letter you want to look. Diagonal, D. Doesn't matter to me. D makes sense for diagonal in my head. You do you. How do I solve this for D at this point? Two steps, one line. What are they? If I multiply by 45, I wind up with this. Don't write it yet. If I multiply by 45, I get 45 cos 82 equals 45 squared over D. I don't know that did it. I'm trying to solve for D, right? Where's D right now? In the orange one. So careful. Just before you try to answer a different question, just tell me where D is right now. Do you want it there? So how do we get something out of a denominator? One more time. I don't want to say you're wrong because you could be right, but there's an easier word. Right now, the right side says 45 divided by D. Do you agree with that?
Yeah.
How do you undo a divide by D? So that's the same thing as divide.
Wait.
What's the opposite of division? Let's multiply. So you said divide by D, multiply by 45, or multiply by 1 over D. This is none of those, and it's a language thing. But if this is what you were saying you would do, and the words were coming out funny, I'm fine with it. Okay, in doing that, they gone. One more step. Okay, D is exactly equal to 45 divided by the cosine of 82 degrees. I don't know what that is. I'm guessing here. If that's 45 and 320, I don't know, 450-ish? No idea. 320.3383? Can I just call it 320.3? 323 sounds better to me. Bars. Cool. 323.2 watts. Boom. Could you write a sentence with this? Do I have to? Oh, I'm not going to. Turn on the captions on the video. Your friend is 323.2 meters away from you. Now the captions have written it right. Cool. Super hard. Like, I hope not. You think any of the problems that we're going to do are going to be particularly hard? Do you guys remember how to do systems of equations? Cool. Good. All right. We get 14 minutes to go ahead and blast through some of these. I don't know where the homework that I had assigned or that I was ready to roll with went, but here we go. For the homework today, tonight, this weekend, I want you guys to call this homework 4.3.2. And we'll start on page 288. We're getting wild. And let's take a look-see. I want number 70. And beyond that, your input. I'm picking 4 more. Between 70 and 77. Look at one that seems like, oh, either it looks super easy or it looks interesting. Or it looks super hard and that's why you want to do it. 71. You got it. Cell phone tower. Or radio tower. 70 and 71. 73 looks like it's going to be interesting. I didn't even read it, but it's got a neat picture with it. Let's do 73. It's a machine shop. I mean, it looks, I don't know, they draw a nice cylinder. They took the time to draw it and put it in the book. Oh, we'll get it. 77 looks kind of neat, doesn't it?
Spider-Man.
What?
Spider-Man was
76.
76.
A long one. Oh, it's long though.
And then just leave it at 76. Because I thought you said you wanted
Do these 4. Do these 4. Right, that Spider-Man song? Have fun. I don't know. Okay, cool. There they are. Do those 4. World Star. For anybody who's at home ill, why ever you're not here, or you guys forgot your book, I'm gonna hook you up real quick. I have to hide answers though. Can I borrow somebody's book real quick? Baller. And get out of here. I also don't remember the numbers, so I'm gonna need your guys' help.
70, 71, 73, 76.
70. You can pause it if you need to. It's on the video. 71. I like that it's called a guy wire. Never heard that term before. I don't know, about 7 letters. 70, 71, 73 was the other one that I thought looked neat. This is a picture for 73, just in case you don't read the thing. This is a picture for 73. That looks awesome. Love it. And 76. Talking about the height of a Spider-Man balloon. And nice little table action. Okay, one comment just so you guys have it on 76, guys. When it says how does the angle impact the height, and it specifically says as it goes to 0, on 76E, this is the like real math notation. As your angle theta approaches 0, the height approaches, and then you're going to put a number right there. What happens, and I think it's the height that they're dealing with. Yep, as theta approaches 0, what does the height h do? Or approach. Cool. You guys get 10 minutes to work on that. Good luck. Have fun.